Our next speaker is going to be speaking on data science from Mars, new methods to study group and space analogs. She's a sociology PhD student at the University of Iowa. Please help me welcome Inga Popovaite.
So, hi everyone. First of all, I wanted to say thank you, Dr. Rupert, for a fantastic talk. And also, you saved me about 10 minutes explaining people what MDRS is and how it functions. So, I will definitely build on your talk. And yeah, so I don't have to talk as much about what So anyway, yes, I'm a sociology PhD student at the University of Iowa. I also do information science, or as you call it, data science. It's like there's different ways to call the same thing. And my dissertation, broadly speaking, deals with gender, emotion, and status in small groups that live and work in isolated, confined environments. So what I'm going to do today, I'm going to talk a bit more about my research, but I'm going to talk to more, kind of suggest to you about different methodology that we can use to access and use the data that we already have to look at group processes in small, confined environments. But to start with, I wanted to kind of start with a very basic background, so that would show you my approach to groups. Because first of all social psychologists would agree that group is more than a sum of individuals, right? There are separate group processes that are in place at work. And as a social psychologist, I said, yes, that's absolutely true. And just a bit of trivia for you all. Social psychologists come from two different disciplines, so they can be from psychology or from sociology. We all agree that group is more than the sum of individuals, and that person's behavior is a function of personality and environment. Or like Lewin in 1936 kind of proposed this like very broad definition. How do you capture behavior? So what psychologists focus on this equation, but they really zoom in into personality. What sociologists do, we say, of course, personality matters. No, there's no dispute about that. However, what we focus on is the environment, and the environment can be understood in a very broad way. It can be your physical environment you are in, can be a social cultural environment, who you are, who you're with, who are you not with, who you want to be with, how do you perceive environment, how does environment perceive you. So that's what we as a sociological social psychology, that's where I zoom in, and that's the main principle that guides my approach. So if you see that I talk barely anything about personality, it's not because I think, it doesn't matter. No, it does matter, a big thing. However, my research area on this equation is the environment. So I just wanted to establish this before we go on. So the big question, are we ready to go? My answer, no. And so what do we need to do to be ready a bit better? Well, we need to study that. As a researcher, I have my own bias saying, well, we need to know something, we need to study. Also, kind of finance need to do that, but that's another thing. So we need to study that. And how do we study people in space? Well, we actually do study people in space, right? So there's like two ways to do that. One, if you have a lot of connections and a lot of money, you actually study people in ISS. Because this is like the golden standard. If you want to study people in space, you actually go and get data from ISS where are people in space. But problems with this approach, you have very small sample size. So for those who do statistics, it's really hard to run significance tests, and you can't generalize as well. Again, hard to access for me as a scientist in her early career. Will I get hands on data, or would I be able to design my own study to carry on in ISS? Absolutely unlikely. So, for people like me, majority of folks in the space analog kind of behavioral studies, what we use so-called space analogs. So let's say Antarctic stations, MDRS, FMARS, high seas, and so on and so forth. So why is it better than ISS? Well, you have bigger sample sizes, right? You have more people, you can test more variables, and also you have easier access. Because first of all, it's on Earth, right? So that makes it easier. So space analogs, great. However, there's always this however in any research, and I hate it. So when we look at space analogs, we still have small sample sizes. And There's a big debate in the field. If you want, you can look these citations. There's a debate on how do we actually generalize our findings. Okay, we found something, we were studying a population, let's say in submarines, right? We found something, so how do these findings, can we say that the same things will happen for people like in MDRS or in FMARS or let's say high seas or in an Arctic research station? So, so it's still a big ongoing debate about generalizability to other populations because again, we still have small sample sizes. Other thing is validity of measures. So, kind of like quick things on that. So one way to make your data more generalizable, so kind of to do a meta-analysis. So you look at a lot of different studies that kind of study the same things, and you look into different findings from different populations. However, then we run into another problem, which is the validity of measures and incompatibility among different research projects, because every person that's measuring stress, they'll have their own stress questionnaire that they think is the best, because like person X, that is their academic inspiration, did that, and that's the way they're going to do it. Another person will use another questionnaire. Some people will conceptualize group cohesion in one way, some people will conceptualize in a different way, and they will be essentially measuring different things. So we have a problem of validity of measures across different studies. And again, access. I'm very lucky to have access to MDRS. However, a lot of like young aspiring scientists, they would not necessarily have the ability to go and get their own data from space analog facilities because that costs money. You need to have connections. You have to be able to travel there. Like there's like a whole big thing that a lot of grad students probably just don't have resources for that. So again, space analog is great, but we can do better. And this is where my partial solution comes in. Data science, another beautiful buzzword of today. And I just threw in a definition of that. It's from Wikipedia. I usually don't use Wikipedia in presentations because, unreliable, blah, blah, blah. However, is this definition as good as any? Because data scientists themselves, they can't really, agree on the definition. So for the purposes of today, and kind of purposes how I approach it, it's a very multidisciplinary field that basically uses data to structured and unstructured data to find patterns and to answer research questions. That's basically what it is. Is that a better word for statistics? Or yes and no. Statistics usually just work with more structured data, and data scientists can actually make sense of unstructured data. So, what is data scientists like? Let's see, like me, what do we do? So when we focus on the digital imprints in the environment, remember the E part from the first slide? Yeah, so that's what we do. Because every time we surface something on the internet, we leave a mark. Every time we do anything, we leave a mark. We leave data traces everywhere we go, everything we do nowadays. And this is data that we can use to study people. It's also very non-obtrusive study approach, meaning that you are not bugging participants who are already doing some of their own experiments. Like, hey, can you fill in my questionnaire? Like, come on, fill it. Write that down. Like, how do you feel now? What have you eaten today? Like, what are you going to do? What are you going to do? So it's like very obtrusive, and it has so-called a research effect, because you being as a researcher in that environment, you already change the results of your experiment or your survey. So that's the very non-obtrusive, because we're kind of looking at secondary data that was generated for other purposes, and we just harvest that and use it for our own research. And you can do it kind of either as an exploratory approach, kind of like throwing everything on one, whatever sticks, your correlations are there. Which you can do because you have a lot of data points, you have power of statistical analysis. Or my what I do is more like theory-driven approach. Actually, I know what I should expect to find because based on all the other studies in that field I had before. So, and then I would just use new data to test my theories and kind of reframe them and make them more correct. So this is how I do data science. So I'm going to give you a couple of really examples. How can it be done in with data that we have? So my first example, this one comes from my dissertation. So I'm looking into gender patterns in crew dominations during MDRS. simulations. Again, Shannon was saying, like, I don't care. And I say, well, I do care a lot. Because I care from like structural perspectives. Okay, let's say stressful situation, who I'm going to listen to. Are we going to, because nowadays what people do in task situations, our biases inform our decision making. Means that, yes, I see that you are maybe are correct, but there's another person who look that they know a bit better, although they might not. But based on my perception on that person, based on the gender, race, class, religion, education, age, any other observable characteristic, I will be more likely to trust that person, even if they're not correct. And stressful situation, that is being accentuated even more, and that can be very dangerous, right? So that's why, yes, that's why gender matters from like very structural perspective, like who do we allow to speak more and make decisions and influence decisions more, and whether it's based on skills and actual expertise or our implicit biases and stereotypes. So, yeah, so in theory is, if you want to pick up any of these articles, there's even more, just like put some more relevant ones. Yes, there is, in any team that was there's mixed gender, men will be more likely to dominate and be more influential inside of decision making. So when I see like, okay, so we have the theory, let's look at the data. And the data I use as EVA reports from former LDRS crews. So, you know what the crews are, so they all have the same more or less crew roles, so I can control the official hierarchy there. And every crew, every time every day they have to file report after they went to an EVA. So I take those reports and I read through them, or have Python read for me, and then I see like who's working with whom, and then I make a co-working network. So that's something like that. So in this case, any node, like every this little circle is a person, and a tie between them is an instance of them working together. So these folks work together less than like these folks, because like the tie here is stronger, you see. Yeah, so this is how my data set looks like in the end when I visualize it. Yeah. And then after that, I calculate centrality scores, basically which person is the most central, accounting for the strength of ties, meaning how many times they went on an EVA, and how many people. Because if a person that we think that is like very important for the mission, right, it's more likely that they will go to more EVAs with more people, because their skill set is being seen as like more important for the mission. That's the reasoning behind this. And then I calculate the probability of a woman or a man being the most central person. And in the end, I take into account their official crew role, seeing whether gender still makes a difference when we account for their official hierarchy. So, so this is what I do. So this is an example how it looks like in real life. So a random EVA report, 2017. So from this one, I would take, there will be a small, so this person, this person, this person, this person, this person, like these 5 people, they have a connection. So, so let's say like, in this case, let's say you would imagine like 5 people and connection between them. And I would read report after report, or have, again, Python do it for me, and kind of build up a network as I go, and kind of like, and so the ties would get thicker between those people who are working together more, like, let's say, like between these folks. And then these ties then later will try the centrality scores. All right, so this is, if you want, I have like more graphs. We can talk, I can show you later, but just like, finding so far from my pilot study, yes, men are more, over 3 times more likely than women to be the most central people in DRS crew. Again, controlling for their official roles. So that's like one way you can look at the data. So another example, okay, great, have time, is sentiment analysis. So what is the sentiment analysis, right? So first of all, my question is there a change in one's overall mood over time? In theory, yes, there's like a 3rd quarter effect. However, if you look into different literature, which I don't, because this is not part of my dissertation. It's like very pure example to illustrate what we can do with data, right? So in theory, that's why there's no citations, because again, I had them somewhere, but I could not dig it out in my head straight away. Again, so yeah, so we know there's like a 3rd quarter effect, but if you read different authors and different experiments and based on different crews, Some people argue that it doesn't, it occurs, but only like very long time. Some that think yes, but maybe in short, and sometimes like, so there's like no consensus, why does it happen and how does it happen, and does it even happen, So in this case, we can also look at the data. We have the crew reports, and we can look at that. And using sentiment analysis, which is a very powerful tool, and those of you who work in marketing, you probably definitely met this beast. It's one of the more popular algorithms from natural language processing, basically where you take a text and you look whether it's more positive or more negative. And the way you do it is you can do it as a supervised or unsupervised models. And it's like very short intro. So supervised models, basically you take a lot of text. It can be comments, it can be reports, it can be journal articles, books, and you need some human people to actually read like a sample of them and mark them. This is a positive, this is a negative text, and then like feed them to your computer, feed it to your machine, and then they would, based on words in those texts, they would guess whether the other texts are positive or negative, based on the information you provide, based on how you train the model. So that's the supervised one. Unsupervised is a bit easier. You already use existing lexicons or lexicons that are available online that already have words marked with like positive and negative discourse. So in that case, you approach a text like a bag of words. There's like so many different words, and each word has a weight that's already been assigned by people ahead of time, and then you just calculate the overall weight of positivity and negativity in any text. So this is like harder to do, it takes more time. This is pretty easy, and this is kind of for demonstration purposes. I just did this one. So yeah, so what I did, unsupervised sentiment analysis, I took data lexicon that's been designed specifically for social media similar domains, words awaited, and I used 2002-2003 field season crews as an example, and I took the commander and reports and narrative reports. Again, these are reports that have to be published online every day, and that's what I have. Again, quick and dirty, kind of show you what you can take text and like put them into these things. So red line is a commander report, blue line is narrator report, and this is like day 1, day like 14. There's one clue that's day for month, that's why it's all skewed that way. And this is like overall compounded negativity to positive discourse, so the closer around 0 is like neutral, this is like more negative, and this is like more positive report. So kind of, so we can guess the mood of those reports. So we can say there is some like variations over time in most of the crews. However, it's very hard to see anything because like if someone would just show me this, I would like, I don't know, there's something happening there. Is there like a pattern? Maybe, but they're like so different. But there's definitely a difference between the narrator and a commander report. I can tell you that. And that's also maybe an interesting thing to see, to study how different people in different roles perceive the mission and how that affects their like mental health and positivity, negativity, and stuff like that. So that's like an example. So now, like quickly, so to do some conclusions here, advantage. Well, data is there. You don't have to actually travel to space analog. You can use data that has been already generated and just read it and study things. And your measures are unobtrusive, so by studying this, you're not changing the situation as there is there. So by me looking into like structural like patterns through social network analysis, or like looking into sentiment scores, it does not affect people who produce the data, so there's no researcher effect there. So that's a big thing. And again, I have way more statistical power. So the crews might be 8 people, maybe 5 to 7 people. However, when I look over time, my data point becomes not a person, but like their instance of the data, like either they're working together or they're like producing a report. So we have like way more data points over time, so we have like more statistical power to get into like smaller things that kind of really find something. Again, limitations. Too much stress in algorithms these days. Like, you see what I did? Like, yeah, so what does it mean? Nothing. You know, it's, but like, it sounds cool. Yeah, it's sentiment analysis. It looks, it's like, but actually, if you don't know the question you're asking, if you get this, so what is your conclusion? I don't know. So that's why like we still put too much stress in algorithms, especially unsupervised ones, and we think that computer knows better. No, they don't. And we need really, when you do this work, you really need to know what you're looking at, what you're looking for, and have your theory ready, have your assumptions ready, and know your biases, where you're coming from, and how you train your data. And again, still we're looking at secondary data, so we don't get at that personality level of behavior, but we're more environmental. Cool. So that was very quick kind of intro on data stuff. You can find, that's my website. I blog there. Also, you can email me. Yeah, let's keep in touch and talk about things. Yes, thank you.
I want to ask you a question I asked Shannon River at the end after her talk was done. Have you studied the Atlantic rowing race at all?
Oh, what?
Yeah. I'll take that as a no.
Atlantic rowing?
The Atlantic rowing race is actually
Oh, like when people row across the
yeah, they row across the ocean. So you have studied that?
I do not like heard of that.
Because there's like this great, amazing group dynamic of like 6 or so people.
Absolutely.
You know, sometimes it's all women, sometimes it's all men, sometimes it's mixed, and they have to make their way across, and they're out in the ocean, making their way all the way across the Atlantic Ocean.
Do you have any books on that, articles on that?
I don't know if any books, but you can just Google it.
Yes, I will. I'll definitely do that.
Limitless resources
Yeah.
on like events and to study like the group dynamics that come out of it, how they work together on a mission to get across the
Absolutely.
ocean.
Because you have that, yes, you have to.
Like well, days.
Oh, yeah. I'll definitely.
Our society.
Yeah.
How did you, in your first example, how did you operationalize your co-working network and neutralities? And just like on search and they were addressing.
Yeah, so co-working, I would look at that list. Who went on that mission. So that's, okay, so that's what we have.
I see, okay.
And neutrality, so maintenance neutrality, so I would account for like the number of times it
Can we
happened.
keep the conversation down so we can get answers to our questions?
And the strength of those people. So I would account for the people who would go to a lot of more EVAs, but also with more people.
I see, so within the EVA itself, how often they talk to each other?
Yeah, no, it's like because we don't have.
Okay, okay.
Thank you, Inga.
Yeah,